I'm going to leave that up for a second. I need to now, with question 2, start looking at a term congruence. What's the term congruence talking about? What in layman's terms? You're talking to a year 5 kid. Same shape and same size. So I need to prove that these shapes are both the same shape and the same size. What are my options for the proofs? SSS? SAS? These all sound like RHS? AAS. So which one am I using here? Which proof? Or, that's or, ASA by the way. Yeah, so I'm using one of these two. So I need to prove that. We can see that's the case, can't we? Is that enough for me just to write ASA or not? No, we need to show that we understand how we're getting this proof done. I'm going to rub this question out above just so we get a nice clear view. So, I need to somehow prove, or to showcase, that these triangles are the same. What should I start with? A side? Okay, what sides are the same? So I've got side AC is equal to side DE. And what are they both equal? 10 centimetres. Very good. What else do I know? Pick an aspect, Ethan, of this triangle ABC. I've done the side. What do I want now? It's not A, it is AC, sorry. What angles do I know? Do I know this angle? So let's start with that one. How do I say that angle? Do I write angle A? Or is that not the convention? What's the convention? Angle? Let's start here. B, A, C. So I write angle BAC is equal to angle. Which angle does that correspond with? EDF. Is it EDF? I want the one that says theta in it. Which one's that?
The E.
Yeah, it is the angle E, so I want to get the angle E, so how do I write that? Where does the angle I want need to go? In the middle, so what? Just pick a letter to go before it. DEF, perfect. Which equals theta. What else do I know? Brody, help me out. Angle, what other angle do I know? In the triangle ABC. The bottom right? It's in the C vertex, isn't it? So how do we write that? Where do we want the C to go? In the middle? So let's go ACB. Sound good? That equals angle? FED. Oh, sorry, FDE. Perfect. Which equals that, which is a poor symbol to choose. Now I've proven that two angles are the same and my sides are the same, haven't I? So I can write triangle ABC equal with the squiggly line on top, triangle DEF. Happy with that? Yep. If I wanted to be extra special, I could write in brackets ASA. And that proves without a doubt that the triangle is congruent. Henry, you're looking pretty excited here, so I want to have your input on the next one. By the way, great tank in your methods class. That was impressive. That was very good. So, what's the difference between similarity and congruence?
Same shape, different size.
Same shape but different size. So they need to be difference by a ratio. The sides need to have the same ratio between them. So how can I prove that? What are the proofs of similarity? AAA. So all my angles can be the same.
SSS with the same ratio.
I'm just going to write SSS ratio. We know what that means. What else? Atari, what do you reckon? Well, the answers are probably up here, not down there. Henry, you want to go back to helping out?
RHS.
Yep. I don't need to worry about that. We know what that means. And SAS. Cool? Bit of SAS. Now, in question A, it looks like I've been given no information, doesn't it? But I have been given a little bit of information. What information have I been given? Ethan, what do you reckon? What can you tell me about the lines here?
They're going down.
They're going down. So why do we have arrows there? Are they the same size?
Yes.
Do they look the same size? Well, I am bad at drawing, so that's a fair assumption though. But I have intentionally drawn them different sizes. What does it mean, Brody? They're parallel. That's important. It's important they're parallel because there's a rule we can get out of that. What's the rule we can get out of that? What do you think, Lucy? There's a special rule, an angle rule that we can use. Even though we don't know what the actual angle is, we can say something about this angle and this angle. The Z rule. So what's the Z rule? Those angles are the same, correct? So I can say, and I'm just going to get rid of that Z rule, I can say that angle BAC is equal to DEC. Am I allowed to say that? Now if I wanted to be really good, I would write what else do I know? Riley, what do you reckon? What else do I know about this shape?
What do you think of this?
So I need to prove one of these. Have I got any sides? Have I got any sides? So anything with an S in it's probably not going to be much help for me. So I'm trying to prove that what? All angles are the same. I've proven that one of the angles is the same using the Z rule. What else can I do, Gabby? X rule. So I can prove that I'll call this one theta and I'll call this one, what do you want to call those angles? C? Let's call them C. Sounds good to me. Although I don't really like the word C, but because we've got C there. Let's make it Q. All right? So I know that angle, help me out. Help me out, Abigail. What angle do I want on the left-hand triangle? Angle. What's the vertex that I want the angle on? Can you read that at all? It's the C. Do you want to help her out, Imogen?
Angle ACB
Equals? Very good. Cherry Evans always gets a run in this class. Queensland joke? No? Because his nickname's Daly Cherry Evans. He's going to lose Origin in a couple of weeks. Well, it takes him a few weeks to lose it. He'll have lost one game by next week. But what else do I know? If those two angles are the same, what must the third angle be? If you know two angles in the triangle are the same, what do you know about the third? It's also the same because how many degrees are in a triangle? 180. That's the same for both triangles. I could also use the Z rule there if I wanted to. So help me out, Laura.
ABC equals
Well, I can't write. You are correct. I am right. ABC equals
CDE.
You say DCE? DE? CDE. That works for me. Yep. Cool. And I could write Z rule again if I wanted. How would I write similarity? What's the way to show similarity? Triangle ABC. 3 lines is triangle. Probably should call it EDC. Sweet.